Let's consider if we have an array A and a randomized select algorithm to find a specific order statistical, and we want to go through the steps of this algorithm by using a concrete array and a specific ith order statistical we want to find. Let's assume we have an array A which contains elements 6, 10, 13, 5, 8, 3, 2, and 11, and we want to find the third smallest element in the array A. So the steps of randomized select algorithm is, the first step is our base case. We check if the subarray has just one element. If so, we directly return that element. But in our case, the p is not equal to r, so initially, since p is equal 0 and r is equal 7, so we skip to the next steps. And the second step is randomized partition. We use the randomized partition to split A into subarrays around a randomly chosen pivot. So let's assume the pivot we select randomly is the value 8, which is at the index 4. So after partitioning, our array might look like this. The pivot placement can vary based on the randomness. Our array A is contained element 6, 5, 3, 2, 8, 10, 13, and 11. So now the pivot Q is at the index 4, and the pivot value is 8. And the third step is to determine the position of the pivot. We just calculate K, which is equals Q minus P plus 1, to determine how many elements are on the left of the pivot, which including the pivot itself. So here, K is equals 4 minus 0 plus 1, which is 5. And the fourth step is recursively selection. Since we are looking for the third smallest element, I is equals 3, and I is equals 3, which is less than K, which is 5. So the desired element lies in the subarray to the left of the pivot, and we just recursively call the randomized select on the A of 0 to 3, which now we get is 6, 5, 3, and 2. And then we just repeat the process partition 6, 5, 3, and 2. Let's say 3 is chosen as our pivot. Then this array might then become the partition to 2, 3, 5, and 6. And now Q is equals 1, which is the index of the 3 in our new subarray. And K is equals 1 minus 0 plus 1, which is equals 2. Since I is equals 3, which is greater than K, which is equals 2, right? And we know that the third smallest element is actually the 3 minus 2, which is equals the first smallest element in our subarray 5 and 6. So a final recursive call to the randomized select on 5 and 6 for the first smallest element will return 5. So it is the third smallest element in the original array A, which is 5, which is determined through the recursive partition and selection. So the average case typically is the random choice of the pivot will split the array into two roughly equal parts, which giving us the recurrence T of n is equals to T of n over 2 plus theta of n, which serves to T of n is equals theta of n log n. So this is the average case scenario. Unlike the deterministic pivot choices, which might be vulnerable to some specific input patterns, the randomization benefit is the randomized select can avoid consistent bad partition, which ensuring that while the worst case is quadratic, it is highly improbable in practice, right? So this detailed example captures the randomized select process, demonstrates how this algorithm is effectively narrows down the search space by using random pivoting, which eventually arriving at our desired order statistical.